Hello and welcome to the presentation of the paper called Klexikon, a German dataset for joint summarization and simplification. This is a joint work between myself, Dennis Aumiller, and my supervisor, Michael Gertz. Let's get right into it. And before we start, I want to motivate the problem that we're presenting here by a simple example of reading a simplified article. Secondly, we're going to talk about the construction of the actual dataset, and then afterwards perform some exploratory analysis to gauge whether the dataset itself is actually suitable for both of the tasks in question, namely summarization and simplification. Afterwards, we're also talking briefly about the future work and open challenges we think are still remaining to have a fully fledged solution for this kind of problem. Okay, so for the motivation, imagine the following scenario. You are a child and you are looking for the information on a new topic that you would like to learn about, for example, an eagle. In your expectation, you find a suitable material, for example, a Wikipedia article, and what you would like is a simplified version that cuts down on the length of the content and some form of the writing style, meaning that this still conveys the same information, but on a much shorter attention span, suitable for children or otherwise mentally disabled people in the context of language learning. In reality, however, this looks very much different, and the write would be something that we can realistically encounter in a simplified article. So this would be of the same length, however, of a slightly simpler writing style, but still oftentimes exceeding the attention span and the necessary conditions for a suitable simplification. So why is this a case? When we're looking at simplification and how it is currently treated in the natural language processing community, we find that it's generally tasked as a translation, meaning that we have a source article in normal language written for adults and a simplified version which is treated as a different language and then simultaneously translated sentence by sentence. Given this sentence level alignment and sentence level treatment of articles, we find that the length of the input article is oftentimes the same or even exceeding in the length of the output article. And the first thing that we propose in our work is mentioning that we should consider instead the simplification of a text as a document level summarization problem. In this case, we instead simultaneously compress the article length and replace hard words and sentence structures with a much simpler form of them. The problem is, what would we need for training data if you're training such a system? And the problem with existing data is that they are mostly provided on a sentence level basis, because this is what the translation systems tend to work with. However, document level resources are barely existent, and when we look at English and German, two languages that are important for this work, we find that there are overall only 4 noteworthy document level resources. To give you a brief idea, we're talking about the number of aligned articles, which we can see is very unevenly distributed, as well as the average number of sentences in the source article, so the normally written text and the simplified version of it. In particular, when we're looking at German, we find that for all of these resources, the input number of sentences is on average shorter than the output length of an article, meaning that we cannot really use those for any form of summarization setting. There is one resource based on Wikipedia and Simple Wikipedia by David Kauchak from 2013. However, this is only available for English and not suitable for German tasks at hand. So the contributions that we provide in this paper is the reframing of simplification as a document level summarization problem with a joint simplification aspect. And secondly, we contribute a large-scale resource of document-aligned articles between the German Wikipedia and a German children's encyclopedia, which we are going to mention in the next step, where we talk about the construction of the Klexikon dataset itself. First of all, some information of our simplification resource. The project Klexikon was started in early 2014 as a resource that specifically addresses this need of encyclopedic articles for children between the age 6 to 13. A major difference to Wikipedia articles is that while the article itself can be written by contributors like on Wikipedia, it is first internally reviewed before it is uploaded to the public. Noteworthy is that it is independent of Wikipedia, meaning that there is no guarantee that each topic is exactly the same as on Wikipedia. However, there is a very strong overlap in the existing 3,300 articles, which are on a diverse set of topics. The number of articles we have access to is slightly less, around 3,100 articles, because we performed the crawling of it already last year in April, which indicates that there is still a growing resource that might be even larger in the future. So the actual strategy that we're pursuing here, and that should address the problem at hand, is we have this notion of a Klexikon article acting as a summarized simplification of a corresponding Wikipedia article on the same topic. And the only thing that would be left for us to do then is aligning each Wikipedia article with a corresponding Klexikon entry, and then with these alignments having a suitable representation for our joint summarization and simplification task. In theory, this should all be very easy, where we have, for example, this article on eagles, as mentioned in the introduction, and we simply link it to the existing article on eagles on Wikipedia, and then we continue with the next article and so on. However, the reality of it is much less straightforward. In particular, one of the problems that we had to deal with was the disambiguation of entries. Only about 90% of the articles that we found had a directly corresponding Wikipedia entry, but for example, if we return to the Eagle website, Eagle page on Klexikon, we find that Wikipedia is less certain what we're talking about. Do we mean the animal? Are we talking about the family name quite popular in Germany? Or do we mean a particular town in the US? And this is not the only case. There are many, many more that we would have to actually manually review. And this is how we currently deal with this. There is no automated resolution of how we can deal with such ambiguous mentions. And again, this requires us to go through about 300 articles that we did not find an exact match for. However, it does not end there quite yet, because another thing that might happen is that Wikipedia, that the content of several Wikipedia pages is merged into one Klexikon article. For example, the first paragraph could be about the actual Wikipedia entry for the biological eagle. The second one, however, might already be on the particular properties of a subspecies, like it's mentioned here. And then the third topic might be on a completely different use, for example, the eagle as a form of heraldry. And to resolve such problems, we again resort to manual reviews of these ambiguous articles. The heuristic that we use to decide whether those are suitable training samples or not is simply judging on a paragraph basis whether about 2/3 of the Klexikon entry can be described by a singular Wikipedia page. So for example here, with 3 different paragraphs from 3 different websites, this is not given, and we would then discard the sample in the end after all. With that, we actually have all the necessary tools to create an alignment and have performed the actual extraction itself. So now we can start looking at the properties of our resulting dataset and some of the suitability issues for simplification and summarization in this setting. The good news is we get around 2,900 articles that we have successfully aligned with the methods described before, and that itself is an almost 3 times increase over the largest previous resource, in particular for German. You can also see on the bottom that in addition, what we have mentioned here is the so-called compression ratio, which determines the number of source articles of the average Wikipedia article divided by the length of the average simplification article. A ratio smaller than 1, as it is the case for both previous resources, again indicates that the original source text is shorter than the simplified article itself. However, our Klexikon resource is the first one that has a significantly longer source text. In fact, it's about 7.5 times longer than the resulting simplified text itself. This gives us reason to believe that it's a very suitable problem setting where we actually need this summarization in addition to the hopefully the described simplification of those articles, which we'll look at a bit more in just a second. When talking about the length of the dataset, it's also quite interesting to look at those. We see both follow some kind of a Zipf's law distribution where we have a lot of shorter articles and then a very long tail distribution towards longer articles. One thing that I want to point out here is that you should factor in the x-axis of the length for Wikipedia and Klexikon articles is different by around a factor of 10 to adjust for the different length properties of both domains. Now that we have a somewhat evenly distributed dataset for our task, the question is, can we actually use them for summarization? And the question is, how do we actually evaluate for that? What we have chosen to do in our case is compare against a set of extractive baselines. These are there to test whether we have too easy or too difficult of a task at hand. And there are different methods that we use for those. In particular, a few popular ones that are generally used is the LREC'22 baseline. For anyone not familiar, this generally simply uses the first 3 sentences of an initial article to form a summary. This tends to be performing quite well on shorter texts such as news articles, which is why we slightly adopt a variation called LREC', which in our case just uses the opening paragraph of Wikipedia, which is slightly longer and usually more appropriate to form a summary from. We sanity check also by using the full article as a baseline. This also gives us some information about the general vocabulary overlap that I will just mention in a second. Two extractive baselines that we are using is Loon's algorithm and a variation of LexRank that uses sentence transformer similarity embeddings. The difference that both of these have is that they are informed baselines, meaning that they do know how long the output summaries should be. So it is expected that their values are slightly better in terms of the resulting quality of summaries than the other LREC' and full article baseline. We also provide a form of upper limit for extractive solutions by having some oracle solution and evaluate everything together with the popular Rouge metric, which basically just gives us an information about n-gram overlap. When looking at the resulting Rouge scores, we find that, as expected, our lead baseline and full article baselines are still not ideal, and it turns out that knowing generally how long a summary should be gives us quite a significant improvement, for example, with the Loon and LexRank scores. There is still, even then, a lot of room for better solutions between this and the Oracle baseline, meaning that we have some suitability for this task, given just based on Rouge scores itself. We note that this is maybe not the full story and are of course aware of the shortcomings, but for now this I think is a very decent argumentation that it's quite well suited for summarization itself. On the other hand, when we're looking at simplification, we tend to also use one of the more popular metrics called the flash readability score, in particular the German variant proposed by Amstadt in 1978. Some more simplistic metrics are the average sentence lengths in the number of tokens, and the average number of words in length of characters. What else we propose is a top 1000 lemma share, meaning that we compute the top 1000 lemmas based on nouns, adjectives, verbs, and adverbs for both Wikipedia and Klexikon, and then compare the number of the usage of those top 1000 words against the overall number of lemmas appearing in the corpus. This is a way to compensate against the bias for longer texts, which otherwise would just mean that Wikipedia would be way worse than it should be in the relative usage. When we look at the evaluation of such metrics, we indeed find that the Klexikon articles simplified quite a bit, and in all metrics indicate such a simplification. For the flash score, keeping in mind that a higher score actually offers an easier article, we find that there is a quite significant difference, and similarly we observe larger score differences for the mean length of sentences and words. And even for our proposed top 1000 lemma share, we see that the Klexikon articles are described by a much smaller fraction of words. In fact, about 82% can be described by the top 1000 lemmas alone. This is quite helpful if you don't have such a big vocabulary, which is the assumption for a disadvantaged reader here. So knowing this information and then thinking ahead, we propose some of the open challenges and the future work. And the problem that we have outlined but not addressed in this work is the lack of a sophisticated system that performs both the simplification and summarization step at once. We have individually verified that it is possible to do this in our dataset. However, there is no sure way how we should integrate this into an existing summarization or simplification system. The problem with abstractive systems usually is also that they are limited in the length that they can handle, and our Klexikon articles exceed this by a factor of 100 to 1000 on average. The other problem is that we only have those document alignments, and they might be not suitable to extract as much information, for example, as a training part for simplification systems, meaning that sentence level or paragraph level alignments would be maybe helpful. However, without manual alignments, that is very hard to extract, given that existing solutions either assume some form of linear progress in both texts on the same topic or tend to work only very well with English. The future work that we tend to focus on now is, first of all, addressing this shortcoming of having no automated sentence level alignments, and we hope to improve some of the German simplification systems by just focusing on that alone. And secondly, proposing a resource based on a hybrid retrieval system that could cut down on the texts and then perform abstractive simplification with existing systems. And the final thing would be the question, how do we incorporate this into existing simplification systems, potentially through the use of regularization. With that, I want to conclude my talk Here's more information on the resource itself, and we will be happy to answer any questions via mail. Thank you.